guys. I'm doing super and best of your health. I believe everyone is ready to attend Container Days 2022. I hope you guys are enjoying it and to the best of your capability. So, yeah, here I am, Pravar. I'm born and brought up in India. I'm working with the DeliveryHero, which is a multinational online food giant based out of Berlin. You can probably figure this out from my awesome virtual background. I'm working here as an SRE in search team under Global Discovery Drive. The best thing about my team is we love challenges, whether it is scaling and optimizing Kubernetes workloads or just hitting bullseye at the paintball. So yeah, coming next, what exactly my tribe does. So in simple words, I would say we just drive the development of a global search for restaurants that are used by delivery heroes, brands like Food Panda, Talabat, Hunger Station across the globe. And yes, we power 50 million plus searches across multiple continents every day to help our customers define food and groceries. So yeah, that's what we usually do. So coming to the main topic, what you guys have been waiting for, how the search tribe and delivery hero or DH approach Terraform infrastructure changes at scale. I think what's useful is to first look at the Terraform at a small scale usage, yeah. And then if we have an individual using Terraform, the workflow is pretty simple, right? We write some Terraform code locally, we do our write, and then we run Terraform plan to see what is going to change. And if it does what we expect it to do, if so, great. We apply the change and then we go back into the loop of making changes, right? So, and as a result of apply, a state file will be generated for Terraform to track all the resources it's created. So this is terraforming at a very small scale, one or two people doing it or using it. But then how do we scale this up to dozens and or hundreds, maybe thousands of people using Terraform? The workflow has to change pretty significantly to accommodate many more people, right? So the first thing you will see is much like you do with an application, like you're not going to have one super app that represents the whole company, right? You are going to break it down into many smaller services and applications that compose it. So in our case, we had applications running across tons of GCP projects, different environments, and they led to different requirements as well for obvious reasons. And on the top of it, many customized Kubernetes workloads on clusters were there. And the main thing, how would you keep up with the Terraform folder structure, right? These are all the problems which we are going to cover up. So yeah, coming to the main tech stack. So just to reiterate, guys, our tech stack looks like the following. We use GCP as a cloud solution, and our entire microservices have been set up on top of Google Kubernetes engine. So it's like Delivery Hero, it's a very huge firm, and there are like many tribes. So I'm just talking about my tribe, which is a global discovery tribe. So we use GCP, but other tribes also use Amazon Web Services. But talking about GCP, we are like, as I mentioned, our microservices have been set up on GKE. We make extensive use of Terraform and TerraGrunt. For those who are new to Terragrant, consider it like a wrapper on top of Terraform, working with multiple Terraform modules and managing remote state. You can just get rid of duplicated backend code. And then we have Atlantis for Terraform pull request automation, so that the setup is centralized and everyone can view the plan and take a decision based on the result, right? And now comes the main part, our in-house DH Infra CLI. So this is a utility to generate and manage Terragrant configurations. So yeah, the main part here is DH Infra CLI, which I'll be going ahead to explain in deep. And in the next steps, I'll like show you how exactly this is designed. Exactly. So this comes the main part. designing of the infra CLI and its corresponding components. So as mentioned in the earlier slide, our DH infra CLI, this is our in-house developed utility, right, which is developed in Python. And we have Dockerized it as well so that it is easy to run and manage. The logic behind running this utility is to smooth the generation process of tag run configs, which further calls to modules, which is written in a separate repo, as you can see below. But how does it do it? So it makes use of Terragrant Ginger templates. These templates can be written using Terragrant built-in functions, right? So it's like DH Infra CLI is in sync with Terragrant templates here. So these templates can be written using Terragrant functions, as I mentioned. So like they are pretty useful to call the respective required modules. So in the main diagram file, you'll see you'll see multiple blocks falling to the respective Terraform modules, and the DH infra CLI adds or removes blocks based on the YAML definition being passed to it, which I'll explain in the later slide. So let's say you want to add some feature in the root module of the GK cluster, like you can see a repo, right, which is of which contains the Terraform code of the GK cluster. Now let's say you want to add some feature in the root module. Let's say a logging definition or min master Kubernetes version. Now you would simply go to the TF repo, right, consisting the main TF files, do the changes, validate the changes locally, and test the changes in the staging environment. And then what you would do is get your code approved and merged, right? And then what we do is we would draft a new release, and then we would edit the GK cluster Ginger template to use the latest release tag so that DH Infra CLI knows what's the latest commit or the tag which it needs to pick. Because after all, the template, the Ginger template, or I would say the Telegrant Ginger template is being picked by DH Infra CLI to perform further changes. So DH Infra CLI should be updated, right? So this was just the internal design of the DH Infra CLI, but how do we use it, right? So the usage of the CLI, the main usage. So now comes the main part. So how do we use this utility to perform the infrastructure changes? So you guys can see the YAML, right? Here in DH search tribe, we manage everything as YAML as code. So that's the beauty of it. We just provide one YAML or complete YAML of the entire project. So here you can see the config, the main which contains the root path, and then the project mapping. So there you can see the Google project name, the Google project ID, Google project number, and the main TF state bucket where we are storing the entire state of the project. And then we have deployments and infrastructure. The deployments and infrastructure here, they are acting as a list, right? So there might be multiple setups per single Google project, and even in the deployments, you see multiple list of deployments. Like for example, you need to deploy Nginx Ingress, you need to deploy Prometheus, you need to deploy XYZ app when you create a single GK cluster. So of course, we won't be doing that manually, right? So all of these things are clubbed into one single YAML, right? So if you see below in the infrastructures list, we see the modules, for example, DNS, VPC. We just type the module, and in the backend, it would just create all the Terragrant configs, which would call to the respective Terraform modules. So, but how would it do this? It would do by running the below command. So DH infra CLI, which is our binary, as I already mentioned, and we are just passing the parameter of the main YAML, which is the project config, right? And as soon as we type this, we like a list of things would happen. Like for example, in this case, it would literally mention everything the files, the Terragrant files which could be created, right? So as you can see here, a lot of files have been generated, or I would say the entire folder has been generated. Now in the previous slide when you saw it, like we were calling VPC, DNS module, NAT module. So as soon as we provided the main YAML file as the parameter to the DHInfra-CLI, the VPC folder structure has been created. The DNS folder structure has been created. Inside the DNS, we have tagrant.htcl, and inside one tagrant.htcl, we are basically adding, or like we have basically added the module blocks, which is calling to the respective DNS Terraform module. So that's how we use Tagrant. So everything in search tribe we use a mix of Tagrant and Terraform. So yeah. Coming to the so like till now we have the Tagrant folder structure ready, but it is not yet deployed, right? So we need something so that everyone in our team can see the plan, right? And based on the output of the plan, we can further decide whether to apply it or not. So we have to come up with a centralized deployment tool. So here we are making use of Atlantis. So what exactly is Atlantis? Atlantis is primarily used for, I would say, Terraform pull request automation. So that setup is centralized and everyone can view the plan and take a decision before proceeding with the Atlantis apply. So if you are familiar with the Terraform Cloud Flow, you can just consider that as instead of using Terraform Cloud, we are rather using Atlantis. And to install it, all we need to do is install it and configure it, and just change the secrets so that it gets integrated to the GitHub repo, and just run the main helm deployment, as you can see. So the entire flow looks like, so our dev makes the changes locally, creates a PR, and then it would, like, he or she would do the Atlantis plan on the GitHub PR, and then if the Atlantis plan looks all good, he or she would get the approval from his or her peers, and then run Atlantis apply. And as soon as the Atlantis apply looks all good, he or she can just merge the pull request. So this is how we do it. So as you can see, we have mentioned Atlantis plan. We like you just need to comment this in the GitHub PR page, and as soon as you type the Atlantis plan, the Atlantis plan would so Atlantis plan in backend is called in Terraform plan, right? And all the changes would be listed in front of you. And if Atlantis plan looks all good, as you can see here, and then you would need to get the approval from the peer, right? And then if the approval is there, then you can type Atlantis apply, as you can see it here. Yeah, so Atlantis apply would then apply all the changes. So Atlantis apply is calling Terraform apply in backend, right? So it would just deploy all the changes which it was supposed to. For example, in this case, we were talking about G-key cluster changes. So all the changes would be then deployed, right? And yes, that's it, fellas. Till next time. You can definitely find me at virtual booth or just send a message on the event platform. All right. Okay. Thanks. Bye bye. Take care.